All right, hello everybody. Today we're going to continue with a specific kind of sequences and series. Yesterday we just did an intro to just what a sequence is and what a series is, and now we're going to specifically focus on arithmetic sequences and series. So let's start with what that looks like. Arithmetic, for either a sequence or a series, just means that the terms increase or decrease by the same amount. So, for instance, 1, 8, 15, 22. This is an arithmetic sequence because each term seems to be going up by 7. If I wrote it as 1 plus 8 plus 15 plus 22 and so on, this would now be an arithmetic series. Specifically an infinite arithmetic series, but again, because the first term added with the second term and so on, you can still see that from term to term, each number is going up by 7. So that's why it's still arithmetic. Okay? So that's how you know if it's an arithmetic sequence or not. The rest is just kind of finding a formula for arithmetic sequences and series, and then actually maybe finding a way to add all these numbers up for a series without having to actually add every single one up individually. Okay, so that's the goal for this lesson. So let's start with an example like 11, 19, 27, and our goal is to find the 100th term. So there are a couple of options here. You could just keep adding 8 until you get to the 100th number, but that might take you a while. We could also try to find a general formula or general rule for the nth term and then use that to find the 100th term. Okay, so before I actually give you a formula for an arithmetic sequence, which will always work, I'll just review the shortcut that we talked about in the previous lesson. When you notice that the list of numbers is increasing by the same amount, you can pretend that that's a slope of 8. So the rule has to be something that has 8n in it. Okay, and then all you do now is adjust so that when you plug in 1 into the formula, you actually are at 11. And when you plug in 2 into the formula, you actually are at 19. And if you do that real quick, notice that when you plug in 1, you actually get 8. Well, we need to add 3 to get to 11. If you plug in 2, you're at 16, and you still need to add 3 to get to 19. So actually, it seems like the general rule would be 8n, 8 times n, and then just add 3 to it. And if you know what the rule is, then actually finding the 100th term is really easy, because you could just plug in 100 for n, and you can see that your 100th term would be 803. Okay? Now, sometimes it might be more convenient to actually just have a rule that always is the formula for an arithmetic sequence. So here's what that looks like. Okay? So for an arithmetic sequence, the general rule for the nth term is a sub n, and then it's first term plus n minus 1 times d which we haven't defined yet, but I'll tell you that D, that's just the difference from term to term. So if things are increasing like they were here, it'd be positive 8 would be the value for D. If the list of numbers, if the sequence is decreasing, then this will be a negative value for D. Okay, but this is your general rule. So if we wanted to, you could also use this formula to find the general rule for the mth term in this example. So using the previous example, using this formula, you just look at first term is 11, so you just write down 11 plus n minus, and now D, you can see that D is 8 because things are going up by 8. And now if you take 11 and distribute the 8 to get 8n minus 8 and combine like terms, you get the same exact rule, that the nth term is 8n plus 3. Okay? So now we'll just do a couple of examples where you work with the formula. For instance, find a rule A sub n for an arithmetic sequence where the 8th term is 28 and the 20th term is 64. Okay. So I'm going to stick to just try to keep things as basic as possible. There are a few ways that you can do this, but I'm going to stick with, if we know what the general rule always is for an arithmetic sequence, then I'm going to use this equation and write down what I know. Okay, so I know that my 8th term is 28. So A sub 8 is 28. And I also know that the 20th term is 64. So A sub 20 is 64. Okay, and now if you look at the rule, in order to find A sub 8, you would have to take the first term, which we don't know, plus n minus 1 times D. But we actually, sorry, I should have plugged this in earlier. Since this is the 8th term, we know that n is going to be 8. Okay, and we can do the same thing with the 20th term. To get the 20th term, which is 64, I have to do first term plus, and now we're using, for n, we're going to use 20, since we're at the 20th term, so plug that in. And now this creates, if you simplify this, two equations. A1 plus 7D equals 28, and then A1 plus 19D equals 64. Okay? So this is what I know. My goal is to eventually have a formula A sub n. In order to have the formula, all I need to know is the first term, and we need to know what D is. Because if I know what the first term is, I could just write it down, and if I know what D is, I can plug it in, and then I just simplify the expression, and I'm done. Okay, in this case, though, I don't have any of that, but I know that from the information that's given to us that these two equations have to be true. So we've seen these before, just with different variables. Instead of x and y, we have a1 and d. We can solve this by elimination if I subtract top minus bottom, a1 minus a1 cancels out. 7d minus 19d equals negative 12d. And then 28 minus 64 is negative 36. So we get that our difference from term to term is 3. And now since I know that d is 3, I can take that, plug it into the first equation. So I get a1 plus 21 equals 28. So now I know that my first term is actually 7. And I'm done. Because the general rule for the nth term of an arithmetic sequence is first term plus n minus 1 times d. So now I'll just plug everything in. First term was 7. The difference from term to term we figured out was 3. So then if you simplify, we have 3n minus 3 plus 7. After you distribute the 3, and then when you add it with 7, you get 3n plus 4. And you can double check that this rule is correct, since we know that the 8th term needs to be 28. You can quickly see that 3 times 8 is 24, and if you add 4, you do get 28. And it also works for the 20th term. 3 times 20 is 60. Add 4, you get 64. So this is what we needed to solve for, and we are done with this problem. If we need to do anything else, you can go from here. So maybe they ask you to find here. With this, you can find any term now. So if they ask you for the 1,000th term, just plug in 1,000 and add 4 and you're done. Okay? But the most important thing is knowing what that general rule is. Okay. Let's try another quick example. Let's say we know that an arithmetic series has a difference equal to 8, and the 70th term is negative 5. Find the 20th term. So this is kind of like the last problem where we have a bit of information given to us, but we're going to go one step further. They didn't ask us to find the general rule. It probably would be a good idea, though. So then I could just plug in 20 and find the 20th term. So that's what I'm going to do first. We'll write down what we know and see if we can find the general rule. So I know that this is the general rule. A sub n equals a1 plus n minus 1 times d. I know that the 70th term is negative 5. So the 70th term will be first term plus n minus 1. Since this is where the 70th term is located, I do 70 minus 1. I get 69 times d, but I also happen to know that d is 8. Okay? And this has to equal negative 5, because my 70th term is equal to negative 5. So if I take this equation here, I can find a sub 1. You multiply 69 times 8, which is 552. And then you're going to subtract negative 5 minus 552. You get negative 557. So all I'm doing here is solving this equation now. Multiply these two together, subtract it from both sides, you get that the first term is negative 557. So now your rule will be a sub n equal to first term which I still don't know. Oh no, sorry, I just figured that out. First term is negative 557 plus n minus 1, and d was 8. So if I simplify the formula, you get negative 557 plus 8n minus 8. Combine like terms, you get that the nth term will be negative 565 plus 8n. So there's your rule. And now to answer the question, if you want to find the 20th term, you just plug it into your rule. A sub 20 will be negative 565 plus 8 times 20. So that's 160 added with negative 565. You get your 20th term is negative 405. Okay? Okay, so now just a little bit about series. All of these were sequences. Now for arithmetic series, again, we're going to skip the formalities. If you're interested in where these formulas come from, I could easily show you. But for now, it's more important that you just understand what the difference is between a sequence and a series and how to actually calculate the value of some of these arithmetic series. Okay? So here are some examples of arithmetic series. And then we'll actually go ahead and compute the value of each one. Okay, so one example would be 1 plus 9 plus 17 plus 25 plus 33. This is a finite arithmetic series. Finite because it ends at 33. So we're only adding these 5 terms together. And it's a series because we're adding the 5 terms. Okay, so this is one example. It could also be written in this form. So we have the sigma notation, let's say from k equals 1 to 10, of 6n minus 2. Or I'm sorry, we have to use the same variable. 6k minus 2. I know that this is arithmetic because it's got that pattern that all our arithmetic formulas have. You know, it's like mx plus b pretty much. Slope, variable, and then constant. Anytime you see that this is linear, if this is a linear formula, that means arithmetic. Okay, so these are really the two ways that you're going to see a series written out. And now your job is going to be to go ahead and compute what these series actually equal. So there's the hard way, which typically would involve actually adding all the numbers up. And then there's an easy way, which involves a shortcut, a formula that you can use that always will work. I mean, certainly these don't have very many terms, so we could actually just add these 5 terms together and be done with it. We could plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 into this formula, and then add all those terms up and be done with it. Okay, but here's the formula. Okay, the sum of an arithmetic series which we're going to call S for sum and then little n is just going to be n over 2 times first term plus a sub n. So it's actually the average of the first and last term multiplied by the number of terms. N equals the number of terms. Okay, so we'll do both of these examples with this formula, and if you want to check these by hand, you can go ahead and do that. So for the first problem, for number 1, I'm adding 5 terms together. 1, 2, 3, 4, 5. So it'll be the sum of the first 5 terms of this series. And according to the formula, I do 5 over 2. And then I just do first term plus last term. So you type that in the calculator, and you're done. You get 85. And if you don't believe me, you can take 1 plus 9 plus 17, 25, and 33. You should get exactly the same answer. Okay? Where would this be useful? Well, we'll do one example here in a minute, but let's finish the second problem. Second problem, we have k equals 1 to 10 of 6k minus 2, so we're doing the sum of all those. If I started to write these out, to get my first term, you plug in 6. 6 times 1 is 6 minus 2 is 4, plus etc. My last term will be found by plugging in 10. 6 times 10 is 60. Subtract 2, we get 58. Okay? So now if I'm actually adding those up, all we need is the first and last term, and we're done. So the sum of the first 10 terms for this series will be n over 2, so 10 divided by 2, times first term plus last term, which is 5 times 52 plus times 62. We get 310. Okay? Let's do one more example now. Find the sum of the first 80 terms in 9, 15, 21, and so on. Okay, so this is an example where the formula is actually really helpful. You don't want to add 80 numbers together. Okay, so first, let's find the rule. The rule, which we can do the shortcut for, or we can just use a1 plus n minus 1 times d, however you want to do it, will give us the formula. So that's 9. Our difference seems to be 6. So that's a sub n equals 9 plus 6n minus 6. So we get 3, plus 6n. So, almost done. I know my first term is 9. I already have that. And the last term is going to be the 80th term. And now that I have my rule, I can go ahead and plug in 80. So it'll be 3 plus 6 times 80. So that's going to be 483. So now to find the sum of the first 80 terms in this series, if you add all the terms in the sequence up, you get n over 2, so 80 over 2, times first term, which is 9, plus last term, which is 483. Type that in the calculator, you get 40 times 492. You get 19,680. Okay, so this is the basic idea for how arithmetic sequences and series work. All right, farewell.